So the next talk will be by Eric Dullin, David Jamet, Steeven, Frosio, Roncalli. And the title is Macro-PK Experiments, Level of Control, Repeatability, Distance Effects, and Confinement Effect.
So good morning. First, I'd like to thank the PA organization for this convention and to invite us to present our research. I will talk about PK. So I'm Eric Dullin from the LAPDC in France, a private lab founded by David Jamet in 2012. And I will present today the work we've done with Steeven Frosio, which is with the PK agents, who was not able to make it today, but will be available in November, I think, with the video conference. So I will quickly go through what we've done on this work before this present work. And then I will show you the method we use for this new experiments. Then we will show the result and we'll go to the discussion and perspective. So our focus is to make a macro-PK experiment on a spinning object. So it's very focused. We work on this since 2012 with a net of practitioners, telekinesis practitioners. Our main target is a plastic cup you can find in retail shop, balanced on a needle in a cork or in a plastic cap. You can use other kind of systems, but the key point is 2.4 grams, so it's really heavier than the aluminum paper that is fold used for pinwheel, which are more about the tenths of gram. We'll discuss that later. So the question about this apparatus is that you have different force that can apply on it. So we look and we work on the fact that we can eliminate different force. So the mechanical, the vibration, the electrostatics, because when you put your hand, you could have some electrostatic effects. And finally, we just keep the main force involved, which is the aerodynamic force, either created by airflow in the room or by thermic action of your hand or your body. And in order to work on this, we make many experiments. So during all the experiments, we make more than 500 trials. And we make some lab experiments using what we call the PIV, which is particle image velocimetry. It's a sorry.
That's okay.
Okay.
Just a little bit down.
Yeah, thank you. Thank you, sorry. And so, which is a technology which gives us the possibility to measure the speed of the airflow around the target. Okay? And so with all this work, we make some publication in GSE and the PA Journal. And the main result is that we have no direct explanation of the movement of the target, because we show that the speed of the air around the target was at least 10 times slower than the target. So we can't be the producer of the movement. So, and to show that, we have one last experiment we've done to see how we can start a target like this, throwing air around, so with a pump. So in the green arrow represents the speed of the air. And so you have here the one which is with a pump. And we need this speed to start the target. And here we have the same experiment, but with a telekinesis practitioner. And you see that he's able to start the target with a very low speed, because this is also the green arrow. So there is, here we are at the 2.4 millimeter per second, and this is 31 millimeter per second. And I can show you the video. It's easy. So here you have the pump, and so we need this speed to start to spin the plastic cup. And this is a plastic cup running with the telekinesis, and you see the flow are very slow. Okay. So that was the experiment we've done until 2020. And I will show you now the new experiment we've done. So the general approach is to have, they say, Peter talk about psi atom. So we could say it's PK atom. So typically the agent is working at home with his own material. He makes some experiments, he makes some videos, he makes some reports. We have a scientific team which analyze the report and the video. And then we have some control experiments, so we go on site and we try to do the same with double camera, you can see after. And so we are able to control what he has done completely. And so I can quick here, the same target, except that when we are in confined environment, we use the pinwheel. And the success is measurement is done by at minimum half turn of the target, because with more than half turn, we eliminate the electrostatic effect. So typical experiment, so the PK agents sometimes make some warm-up. We try to make some try to move the target, but just like that, not without any measurement. And then he look at his mood, so very quickly, are we happy or not? Are we in confidence? And is it stressed or not stressed? And then he sets the target, he sets the camera, he takes his video, he makes the trials, he makes a report, and he puts on the net, on the drive, and we are able to analyze this and make a commentary report on it. So the PK agent, just to have some background of his profile. So in the use, he had some experience in OBE and some other Psy experience. He starts PK in 2011. He stopped in 2015, and then he come back to the PK in 2020, but only working with the lab. And he's really strongly involved in the process, so he talk about himself as a research practitioner. Okay, so that's very important also, because he participates to define the protocol and the way it works. So just to give you some example of experiments. So for example, this is an experiment in partial confinement. So why I say partial confinement? Because you have the plastic cup here, and then here you have a little space, so it's not a full confinement. And the idea is to try to run.
C'est bien parce que là, avec des rapports bien établis.
Je vais vous ôter pour l'instant, je vais vous ôter le. Okay, so you can see that he puts the ball on the plastic cup, and then plastic cup is running. And so when he make at least one, so here it's several turns, he decides that it was a hit, so it was a success. And he repeats the same thing several times. So when it is a 17 experiment, and there is around more than 100 trials around this experiment, and we get a 91% ratio of success to start the plastic cup. And so when we talk about control experiments, so I went on site. We make some vibration measurement to be sure that there is no vibration. And we say we did the same kind of experiment. So you can see here. First, we want to start from still. So there is no move before he takes the ball. Then you can see that it starts running. And then we try to make the same experiment using only plastic cap. So the hand has not to take the ball. So you see that now it's trying to spin the target without touching the glass ball. And then we can see that it's running, and after he spaces the hand, okay, and the target was still running. So it was a way to control that all the trials you have done before are in the right direction. Then we make some experiment at a distance. So he puts the plastic wheel, and it was from 4 meters distance from the plastic wheel, and he was able to launch it. So here is the plastic cup, and then so he's at 4 meters of distance. Okay. And on this experiment, it was at 75% ratio. But this was not a control experiment, as you can see, because we have only one video, and he was alone. So then other experiment was more about confined environment. So there is two glass balls embedded. And so on this experiment, he was able to have a success rate of 58%. And with a run of the pinwheel, so you can see the pinwheel here, which is just a fold aluminum paper put on a balance on a needle. And so between the average run was 1.5 minutes, and it moved up to 13 minutes. Okay, and so we make some control experiment on this on site. So here is another camera taking the whole place. So you see that the table is in glass, so you can see through. And we have also measurement of the vibration. And so if we look to the video, so first setting in place the ball around the target. Okay, so kick. So you can see the target is running. One of the targets is running. Okay. And then the two targets are running. So the second one behind start to run. It was 1.5 minutes, 1 minute half later. And then 4 minutes later, you can see the start of the target in the same time that you saw there is no vibration. And with full control of the room in the same time. So this was time, okay. So our other experiment was to combine the confined environment with distance approach. So you make 19 trials with 15 success, and I will show you one with a double camera. So first setting in place the target and the ball. Then you take another camera and get out of the room. So you can see the first camera is here, looking at the target, and he is behind the door. And you can see that the second target is starting to run too, very quickly. In the same time, he's looking to his dog. So he's not really focused on the target. And they are spinning pretty quickly for a double confinement. And then you come back and then you run, and during 10 minutes, the things are running. And so we do a control experiment on this too. So I was able to do that there. So we have a double camera also. So if I just go to the video. So first, setting in place 2 pinwheel with a ball. Then we can see that it's running and there is no vibration. Check. Sorry. Just forget that. Yeah, so after I ask him to climb in the stairs, and then the pinwheel stops. Okay. And he come back, and then the pinwheel spun again. And so I decide to put a second camera to see in the same time his position and the the target. So he was here, he was about 1.5 meters from the target, which was still running. And then I asked him to go again in the stairs. So the stairs are here. So he go there, and he climbed it. So it was behind this hole, this partition. And the pinwheel starts again to spin slowly. And then I think we can see him going down from the stairs. So it was really from a distance and blind. And the last kind of experiment is about control. So it's okay to say that the pinwheel are moving, or the plastic cup, but is it able to mentally address it very precisely to say, I want to start, I want to stop? So we focus on, because of with this kind of picky agents, sometimes the things are moving alone. So the problem is to define when you start the activity, the activity at the beginning, and then to look at the change of activity and to make some correlation between the signal, you can say, and the change of activity. So I will try to put... So on this one, you have to hear the top, because he say top when you want to start or to stop. So here he give a top, and there is a small move on the target. Then she come back and she move again, and then I think it was in. So there was no activity during 70 seconds, and then in 2 minutes. Oops. Rien du tout. Sorry. So here you make a new top to stop it. So just say stop, and you can see that the target is starting to stop. And then the next step is at 3 minutes 30. Up. Okay. So it was again stable. So there is a new top, and it takes a little bit, that more than, I think, 5 seconds to start to move again. So the problem is how to analyze that. And so I propose to use this kind of approach. So on this graphic, here it's no move, no activity, 0, and 1 is with activity. And so during this 70 seconds, there was no activity. Then there was a top and a small move and another move, and then a full move. And then here, he was running, and then he gave a top, but the decreasing of the speed was here, so just a little before. Then there was no activity, and he put a top, and 5 or 6 seconds later, the target moves, and then it moves here. So the idea about the approach to work on this is to look at what's the probability that the order, the signal he gave, was in this space, so at 2 from the delay, compared to the total of non-activities. So in this example, the probability that the order is in this space compared to all this is 2 on 9, okay? And we use the same approach to the global sequence. So we have one chance in 70 for the first move, Then we have 3 shunts, because it takes 3 seconds after the deceleration, about 89, and 6 shunts about 53. So globally, it gives this kind of probability. And if we want to be a little more tough, we can say that we don't want to take into account the little first move, only the large move of the first time. And in this case, we get to this probability. So this is, I would say, a new way to work on this kind of experiment. And we are trying it. So it's an ongoing process. The idea, I will show that in the conclusion, is to make more random generation about the top, the emplacement of the top. So in conclusion, about the method, the fact that we use PK at home gives more trials, and it gives more information and data, if you want to take Peter, to work on this. The repeatability ratio is important because in any experiment I show, it's about 50%. I have no more video, that's okay. It's 50%, so we don't see any decline effect. So it's a little contradictory with some psi theory, but clearly on all these experiments, we didn't have any I would say even ellipse could be sometime because there is some things could happening differently, but the repetitivity is above 50%, so the decline effect is not really observed, and even if we have a full documentation. About distance impacts, we have more questions than answers, because we can say that if you follow world paradigm, it's about to say that we have a decrease of the square of the distance. But in our experiment, for example, one of the experiments I show you, we look more at some like of a connection with the target. He was able to be connected at the last climb in the stairs, and the target runs, and we didn't see any decrease of speed according to the distance. So this has to be worked on in the next. And also we want to try to make some experiments through the internet. We have already done that, but we want to make some experiments with more protocol. About confinement, also questions, because when we put a glass ball completely, it's really more difficult to run the target. So again, it's questions. Is it a problem of access to local energy? If the air is confined, you don't have access to the air outside, so we don't know today. And our next move on this is to work with some environment where we have a partial void, so as in this experiment that we are setting in place. The level of control, we show that there is some synchronization between the signal and the move. Thank you. So if we want to really have a probability approach, we need to make some kind of random generation of the placement of the top. And so the PK agent has to follow this placement. So we have the interpretation of by premonition, for example. Okay. So thank you again for your attention. And if there is any questions, and if you are interested with other information, we have some links here you can have, and I will be happy to answer.
Thank you, Eric. So time for a couple of questions. Ramses?
Thanks, Eric. Wonderful presentation. I know you have been working in this initiative for a long while. I was wondering if the participants that you are working with have reported better results around you, considering the experimental effect and your continuous interest in this. Have you think or have you analyzed the possibility that you're also helping in the movement?
Yeah, you are right. It's always an issue, but I'm not able to do what are doing PK agents. I make some telekinesis myself, I agree, but not at this level. And also, when I met the PK agents, they were already doing PK before me. So I think, yes, maybe because I am involved in this, it's better to federate people and working, and you know what they can feel and so forth, so they stay in the club and the lab. But I don't think this effect has experimental effect. Well, you always ask the question, if he's in the outside the door, maybe it's because it's me close. But we saw some video where he's alone in his house, and he get out of his bar and it's working. So no, thank you.
Hi, Eric.
Yeah.
That's a nice presentation. I always find it so bizarre. It's so really wonderful that you're working on macro-PK.
Yeah.
Question about so obviously to do it under vacuum was really, what you want to do next. And you said you said a partial vacuum. What did you mean by the partial vacuum?
I think it's around 0.001 bar.
Okay, because
so 100 current pressure divided by at least 100.
Yeah.
So we already have put the experiment. But
okay, just the one thing, it's very easy to calculate the pressure at which you would not be able to have any convection.
Yeah, but we have developed some tricks to do that, in fact. So our idea is the same that when you say you have to be able to share the experiment. So the first experiment we've done with our laser and so forth, it was a bit complex, and so people have to read the article to really understand what's about. Except when you see the flow of the pump and the flow of the telekinesis. But this experiment with void, partial void, will be clearly, you see it, if it works, it's clear. Because we have some apparatus to show that
my only point was that there's just a certain pressure which is not difficult to attain, at which you can be sure that you're not having any convective forces, and that's just good to state that and have that number. That's all. Because then
I just wanted to mention that above the fact that we have a complete measurement, detailed measurement of the pressure, so we can see the number. We also will use an apparatus, so people can see that normally the pinwheel is not moving with this air.
Yeah.
Because we want to use a kind of blower inside it. So if this blower is full, you can't move the pinwheel.
Okay, we have time for one short question, one short answer.
I've actually had some video films sent to me that are rather similar to this. I wonder if you have access to the target material. Do you provide it, or do the subjects provide it? In my case, when I'm looking at it, obviously I don't have access to the material, and I look at it rather skeptically for explanations. The usual method that magicians would use would be some iron filings under the nails or hidden and some magnetic effect. So that it's crucial that you have access to the targets and the target material and so on, that you can examine it. And I wasn't sure how many people are using these special, 1 or 2 special subjects, so maybe you can tell them all the details.
First, I'm using myself the same kind of material, and so, for example, for the void experiment, I will have the same, so I can test exactly the same thing. For the point of magnetism, yeah. So we have a double material for the void approach. Also, we are working with the PK agent from years. And so we don't see how this guy wants to make trick and spend time every day to make tricks because he makes reports so forth. So that's another point, but that it's important to take into account. And then we already use also our own material. So when I bring on site, I have my own pinwheel, so he can work with it with its own, but I can see also what he's done with mine. So I think that on this part, and we make a full job, and maybe you can see that on the paper, about magnetisms, electrostatics, and so forth, to be sure that we have eliminated all this kind of forces. So we are really on a specific approach where we have no answer to why these pinwheels or plastic cup are running inside.
Thanks, Eric. Now,
thank you.
now it's time for coffee.